distance formula. Here is a clip from our SOL formula sheet. These are geometric formulas. These are just some of the ones that you are given during your course in geometry and when you take the SOL. Here's a right triangle with the legs labeled A and B and the hypotenuse labeled C. This is called the Pythagorean theorem. It's useful to have memorized, but notice that they give it to you. This is another one that is pretty useful. Notice there's a circle and the radius is labeled R with the center point labeled H, K. Remember that H, K is an order pair, so the H represents an X value and the K represents a Y value. Notice that R is a length. Keep in mind that any length is always positive. Notice they give you a formula to find that length R. The quantity x minus h squared plus the quantity y minus k squared equals r squared. This formula gives us the length of the radius. Let's keep this in mind as we explore the next example. Finding length, sometimes we call it distance between 2 points, in a coordinate plane. Example, find the length of the segment with these endpoints. P is 0, 2, and R is -4, 5. We're going to start by using the distance formula. Now, what is the distance formula? Well, looking back at our formula sheet, we remember that they gave us a formula for length. We can find the length R by making the R squared not be squared anymore. How do we undo the squared? That's right, we take the square root. And that gives us just R. We don't put plus or minus because we remember that length is always positive. Normally, solving an equation, we would write plus or minus, but length is always positive. Let's copy this formula down, but using, instead of R, we're going to call it D for distance. So our distance formula, let's write D equals the square root of quantity x minus h squared plus quantity y minus k squared. Now remember that the h and k is just another point. So over here, we've got our x and our y, and the other point, h and k. And now we just substitute those into our formula. So D equals the square root of the quantity x minus h. X is 0 minus h is -4 squared plus y is 2 minus k is 5 squared. Now, if we're going to use a calculator, we can type it in right away. In our calculator, I'm going to start by typing the square root. Second, square root, parentheses, I'm going to type it exactly like it says. 0 minus, now I need the negative button, that's down here, 4, close parentheses, and type squared, plus, open parentheses, 2 minus 5, close parentheses, squared. I have everything typed just like we wrote it, so now I press enter, and it gives me the value right away, simplified. The value is 5. And I'm done. Now, if we didn't want to do it with a calculator, let's see how we remember our order of operations and our arithmetic. This would be the same as 0 plus 4. 0 plus 4 is 4. So 4 squared plus 2 minus 5 is -3, so -3 squared. That makes square root of 16 plus 9. Remember, -3 times -3 is positive 9. Remember that when we find length, that is always positive. We square the numbers, we get a positive. We take the square root, we get a positive. This makes 16 plus 9 into 25, and the square root of 25 is 5. But straight from here, we can use the calculator to also get 5 right away. Let's look at another method. This is a method where we would plot the points in a coordinate plane. So let's begin by drawing our x and y axis. I notice that I have negative numbers and positive numbers. So I'm going to draw my y-axis. So my x's are mostly negative. I'm going to draw my y-axis all the way over here. Label it y with positive up here, negative down here. And then I see my y numbers are all positive. So I'm going to draw my x-axis pretty low. Label it x, positives to the right, negatives to the left. Now let's plot our points. P is 0, 2. 0, 2, that's right here. Label it with point P. R is negative 4, 5. 1, 2, 3, 4. Whoops, from the origin. 1, 2, 3, 4. 1, 2, 3, 4, 5. And we'll label this point R. Remember, it says find the length of the segment with these endpoints. So I'm going to connect the points to make the segment. Similarly to how we did midpoint and endpoint in the graph, we're going to do distance or length, where I draw the triangle. Moving from left to right, I have to go down first. How many units do I go down? 1, 2, 3. So the change in y is negative 3. Then I have to move in the x direction 1, 2, 3, 4. So the change in x is positive 4. Notice that we've made a right triangle. Do you remember the formula we saw earlier? That is a right triangle. Let's go back and look at it. It's this one, the Pythagorean theorem. A squared plus b squared equals c squared, although we usually like to write it c squared equals a squared plus b squared. Let's practice it that way. Taking this back to here, let's write down that Pythagorean theorem. C squared equals a squared plus b squared. Remember, they indicated that c was the hypotenuse, and c is the length that we don't know. So for now, I'm going to leave it c squared. A and b were the other two sides. In this case, we'll use the delta y for a. So a is negative 3. Negative 3 squared plus b is 4, so 4 squared. Anytime we square a negative, we get a positive. Remember, length is always positive. So c squared equals 9 plus 16. So c squared equals 25. And then I take the square root to make the square go away. Now I always write plus or minus when I take the square root in an equation, but since length is positive, I only use positive 5 for this length. Notice this is the same value we got when we use the distance formula. Now there's a third way. Let's take a look at how to do it without using a graph. Let's write down the 2 points that were given. 0, 2, negative 4, 5. Again, let's examine the delta x and delta y. This is our x, these are our x values, and these are our y values. So examining delta y, how do we go from 2 to 5? We add 3. Examining our change in x, how do we go from 0 to negative 4? We subtract 4. So remember, the a was the same as delta x, and the b was the same as delta y. So when we think of the distance formula, we can think of it as square root of change in x squared plus change in y squared. Now, this symbol, I'm saying delta, and what it means is change. Just to recall, let's plug them in. Change in x is negative 4, the way I did it here, and change in y is positive 3, the way I did it here. Notice that that's different from when I counted in the graph, but I'll still get the same answer because remember, anytime we square a number, it's always positive. Negative 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, and the square root of 25 is 5. Same answer, just another way. Thanks for watching.